I'm now going to teach you about a concept that you learned back in high school, the concept associated with this thing called pH. pH is a phrase, a couple of letters, that is absolutely ubiquitous in our daily lives. Everybody's always excited about the pH of things. What's the pH of your hot tub? What's the pH of your coffee? What's the pH of drinking water? What's the pH of that acid you threw on the ground? Everybody wants to know the pH. The point about that is we develop these sort of universal truths about pH which allow the layperson, the common person who doesn't clearly understand science, to have a feeling for what a pH is and use it in a practical way. So if I said to somebody, what's the pH? And then I said, it's 7, there's immediately this kind of soothingness that comes over them. pH 7, that's what, neutral, that's normal, that's a good thing. pH 2, oh, that's bad. pH 9, oh, that's bad. Anything other than pH 2, excuse me, pH 7, bad. That's what people think when they hear the word pH, and that's why when you go buy your pH paper to check your hot tub, your swimming pool, whatever else, your science fair project, that's the general mentality you develop. Let's just find out what that value is, somewhere in the range of 0 to 14, but we'd like it to be neutral. Now, having said that, you have to ask what the origin of this notion of pH is, and it comes from an appreciation of this little letter p. This little letter p is a function, and here's what this function is. The little letter p says, take anything that you can think of, any amount, x. Take the log of that amount, and then take the negative of that amount. And that is your px. So anything you want to stick in there right there, take minus the log of it, you get to call it a p. So what if we take the letter h and minus the log of it? Well, that will be called the pH. What if we take the Na and take minus the log of it? Well, that'll be the pNa. What if we take a coffee cup and we take minus the log of it? Well, that'll be p coffee cup. That's all this is. It's a simple mathematical function on your calculator. Hit the LOG button, hit the negative button, you've p'd it. Now, having said that, why do people go to the trouble of creating this thing where you p everything by minus the logging of it? The answer is because, very simply, people like numbers like this. They do not like numbers like that. People like numbers like this. They do not like numbers like this. All the p does is allow us to take exponents, typically negative exponents, and remove the 10 and the minus sign. See what I've just done there? Logging this takes away the 10 to the x part. Putting a negative sign on it removes the minus. So watch me p this thing. Watch me p this thing. Isn't that kind of neat? That's what you're doing every time you take the p of something. Well, since people mostly talk about pHs, evidently people like to take the p of something that's an H. Well, I haven't really talked about H's anywhere that I can think of in this conversation about the autoprotolysis, the autodissociation of water, but I have talked about H+. And that's actually where this origin comes from. When I'm doing the dissociation of water to make H+ and OH-, and I've just finished telling you that the autoprotolysis, the autodissociation of water, is 10 to the minus 7, and the autoprotolysis, autodissociation of water, gives a hydroxide of 10 to the minus 7. When I have these two values right here, if I want to p those values, watch. I've just p'd the H+, pH+. I've just p'd the OH-, pOH-. Except that when I show you H right here, I haven't gotten rid, I've gotten rid of the plus sign. And that's unfortunate. It leads people to this sort of annoying This representation of what it is that's going on, it's not hydrogens that you have the dissociation of. This is not a hydrogen atom that's dissociated. This is a proton, a fundamental particle. It is not OHs that have dissociated. It is OHs with an electron attached to them. But maybe to save space, maybe because they know people don't like having to see 3 things when they can see 2, they've come to call it colloquially the pH or the pOH. But it is, in fact, always associated with this dissociation process and with the ability to take a large negative exponent number and remove the 10 and remove the minus so that you have usually just a small integer value somewhere in the range of between 0 and 14. So that's the origin of the pH and of the pOH.